We've already looked at how to graph exponential functions, and if you remember, we could always find our 2 points 0, 1, because y equals a to the 0 power is always 1, and the point 1a, again because a to the first power is just a. Since we know that logs are the inverse of exponentials, the log equations are always going to have the point 1, 0. Remember, in an inverse, we switch x and y, and a 1. The other point that they're going to have that's going to be helpful is going to be 1 over a and negative 1. We'll look at why that is in just a second. So let's take an example such as y equals log base 3 of x. The points we're going to have, we're going to be 1, 0, 3, 1. This is your a value here. And then the point 1 over 3, negative 1. The reason that's true is if I plug in negative 1 for y, log base 3 of 1/3, we can see that 3 to the negative 1 power equals 1/3. And based on our laws of exponents, we know that's true. Once you have these 3 points, so the 3 points again are 1, 0, a 1, and 1 over a negative 1, you can graph the log equation. 1, 0, 3, 1, and then the point 1 over a negative 1. Notice it's going to approach the y-axis and curve up. This is the inverse of what the exponential function would be, which remember would be reflected across the line y equals x. If we move down and do a second example, consider something like f of x equals the log of 1/2 x. Our points are going to be 1, 0, 1, a1, which in this case is going to be 1/2, 1, and then 1 over a, which is going to be 2, negative 1. So we can then plot those points, 1, 0, 1/2, 1, and then the point 2, negative 1. And our graph this time will proceed down. The same rules apply for translations of these graphs. So let's consider something such as f of x equals log base 3 of x plus 2 plus 1. Start with our most basic graph, which is just log base 3 of x. Our points there are going to be 1, 0, 3, 1, and 1/3, negative 1. So if I plot that, I have 1, 0, 3, 1, 1/3, negative 1. So my original graph looks like this. We know what's inside the function is going to shift it left to right. So this is going to go left 2. So this point moves 1, 2 to here. This point moves 1, 2 to here. And this point moves 1, 2 to here. So this is our first movement of our graph. And then this point is going to move it up 1. So we're going to go up 1, and up 1, and our final graph will look like this. A second example of a translation, if we have log base 2 of negative x minus 1, our most basic graph is going to be log base 2 of x. So our points are 1, 0, 2, 1, 1/2, negative 1, which gives us a graph that's going to look like 1, 0, 2, 1, and 1/2, -1. We can move to the right 1 because if we do the opposite here, so we're going to go over 1, over 1, over 1. And then this -x, don't forget, is going to reflect it across the y-axis. So we're going to come to here, and to here. And so we reflect across the y-axis, and that ends up to be our final graph.